system of equilibrium. Consider a body. Consider different number of forces. If there are number of forces acting on the body, and if this body remains stationary, that is, it does not move or it does not rotate, it is having system of equilibrium. So it does not move either or it does not rotate. This is the example. Suppose consider a stone, forces are acting, it remains stationary even if forces are there. Now in this case, in this system of equilibrium equations, equilibrium equations are coming from resultant. As body does not move, resultant is 0. And when resultant is 0, summation of horizontal forces equal to 0. Summation of vertical forces equal to 0. Summation of moments about any point equal to 0. These are three conditions of equilibrium. So when you are given example, and in that it is stated that the conditions of equilibrium are satisfied or system is in equilibrium, you can make use of these equations and solve the problem. We'll take simple example. Simply supported beam. Now this is simply supported beam with loading. Now in beam problems, there are three types of supports. There are three types of supports. First is hinge. This is called as hinge support. Second is roller. Roller is shown in figure. This is first type of support. This is second type of support, and third type of support is fixed support. This is fixed. Now in simply supported beam and cantilever beam, there can be hinge, roller. Now this hinge and roller can be at different points. I will explain how those supports are. Now for hinge support, there are reactions. For hinge support, there is vertical reaction and horizontal reaction. Whereas for roller support, there is a reaction which is acting perpendicular to roller support. For example, if roller support is inclined, in that case, reaction will be perpendicular to support. If it is like this, reaction is like this. If it is like this, reaction is like this. Now fixed support. For fixed support, there are three reactions: vertical reaction, horizontal reaction, and movement. Vertical reaction, horizontal reaction and movement. Now first we will take simple example. I will give example with magnitudes so that you will more better understand. First simple type of support, let us consider at one end there is hinge, at other end there is roller. Now on this beam, suppose the span is 4 meter. And this is A support, this is B support. Very simple example we will take. At the center of beam AB, this is beam AB, there is a load acting 10 Newton, that is 2 meter from A. Now the problem is to find reactions RA and RE. Now it is by common sense you can understand there is no horizontal force, so there is no horizontal reaction. Even if hinge is there, there is no horizontal reaction. So what are the reactions? If you want to specify, suppose RA plus RB is equal to L, and it is symmetrical. I don't go in make more equations. So each reaction is equal. Therefore, RA equal to RB equal to 5 Newton. So here 5 Newton force or 5 Newton reaction. Here 5 Newton. So even if hinge is there, it is not necessary that two reactions present. If inclined load is there or horizontal force is there, to balance that horizontal force, reaction at hinge will come in horizontal direction. Now we will take an example. Another example. Now before that, I have forgotten types of loadings. Loading types. First load is point load. This point load may be 1 in number or more in number. Second, it is called as uniformly distributed load. Uniformly distributed load. Now what is the effective load? Suppose W is the load in Newton per meter run, and suppose L is the length over which it is acting. This is to explain. Now what is the total load? Total load is W into L, because W Newton per meter and length is L, so multiplied by L. So what is its value? W into L, W Newton per meter into meter means it will be in Newton. And where it acts at the center. So WL, it is L by 2 from the center. So first is point load, second is uniformly distributed load, third type of load, triangular load. At one end load is 0, at other end W same Newton per meter, and these loads act in this fashion and so on. Now in this case, what is the total load? What is the effective load? Effective load is nothing but area of triangle multiplied by intensity of load. This is called as intensity of load. Intensity of load at one end is 0, at other end is W. So what is the area? 1/2. Suppose L is the length. 1/2 into L into W. And here also the unit is Newton, because Newton per meter into meter. Now where it acts? It doesn't act as that in case of second case. It acts here. Suppose L is the length. It acts at 1/3 the length from right end. L by 3. So 1/2 into L into W, Newton, acts at L by 3 from right end, not left end. Because if you find out the center of gravity, it is area. Its center of gravity acts at 1/3 the length from base. This is the base. To give example, suppose point load is 10 Newton. It will act at the point where it acts. To give example. Second case, suppose intensity is say 10 Newton per meter and the length is say 4 meter. Then the load is 10 into 4 equal to 40 Newton and acts at 2 meters from left end. Half of 4, half of L, that is, it acts at 2 meters. This is first case, second case, third case. Now third case, suppose length is let us take 6 meters to simplify, and let us take W intensity to be say 3 kilonewton. 1 kilonewton is 1000 meter. 1 kilonewton per meter. We will calculate the load. We will calculate the total load, and we will calculate or we will find out the point at which it acts. Now, as in this case, as the equation states, its intensity is 1/2 into L is 6 into W is 3. So 6 into 3, 18 upon 2, 9, and what is the unit? 9 kilonewton. And where it acts at L by 3. What is L? 6. So 6 by 3, 2 meters. So this becomes 2 meter in our example. Once again see, 0 at this end and 3 kilonewton meter per meter, not Newton meter per meter, but kilonewton per meter at this end. And total load 1/2 L W, 1/2 6, 3, 9. So here 9 kilonewton acts at 2 meter from this end. This is this total is 6. So from this end, if you want, it is 4 meter. 4 meter per meter. Hello? We will take actual examples on simply supported beams. First, we take simple example. Using conditions of equilibrium, we can solve simply supported beam problems. Consider a beam at one end hinged, at other end rotor. Now here I will take little bit addition of two types of loadings. Suppose 8 Newton This distance is 2 meters. Suppose this is 2 meter and this is say 2 meters, and intensity of load, this is UDL or uniformly distributed load, say 6 Newton per meter. This is NA, this is point B, this is point C, this is point D, this is point E. Now, to find RA and RA. Now, in this case also, as that in previous case, there is no horizontal load or there is no inclined load. So, reactions are perpendicular to support. At the same time, they are in vertical direction. Loading is vertical, so reactions are. Now, what is the total load of 6 Newton per meter over CD portion? It is 6 into 2, 12, but it acts at center. 12 Newton, which is at 1 meter from C. Let us call it as F. Now, conditions of equilibrium. Sigma, now in this case, sigma V equal to 0. Sigma H doesn't exist. Suppose RA is the reaction. RE is the reaction. Our problem is, what is RA? What is RE? Now sigma V equal to 0. RA. Now this is downward, so minus 8. We have considered upward positive, downward negative. Now this is, what is this? 12 minus 12. What is RE? Upward plus RE equal to 0. Or in simple words, RA plus RE equal to 20. This is one equation. Now second equation, sigma m about A equal to 0. Now take moments of all forces about A. What is the moment of 8 about A? 8 into 2, it is in clockwise direction. Once again, refresh whatever I have taught. 8 into 2 is clockwise and in positive direction. So 16. If you want to write 8 into 2. Now what is the moment of this 12? This moment also is clockwise. So plus 12, take bracket, 12 into what is the distance? This 2 plus 2, 4 plus 1, 5. Now is this complete? No. RE, moment of RE. What is the moment of RE? In anti-clockwise. So minus RE into what is the distance? Total distance. Sorry, this distance is 2 meters. So 4 plus 4, 8. 4 plus 4, 8. RE into 8 equal to 0. Summation of moment. Simplify. So 8 RE. 8 RE goes on this side, equal to 16 plus 12 6 equal to 76. So RE equal to, therefore RE equal to 76 upon 8 8 9 72 8 9 72 4.5 Newton. But what is Ra plus Re? 20. Putting Re in this equation, here you can write, so it will be more easy to understand. Put Re equal to 9.5. So Ra equal Ra plus Re, it goes on this side. Ra plus Re means equal to 20 minus Re. What is Re? Minus 9.5. So this is equal to, if you consider 10.5. So Ra is 10.5 and Re is equal to 9.5. This is the example in which simple case is taken, in which there is no inclined load or even there is no inclined support. You got it? Little bit complicated case. One support is hinged and other support is roller, and that roller is inclined. Suppose this is A, this is B. Suppose total distance is say 10 meters. Now here, again to simplify, I will not take inclined loading because that will be difficult to understand. That I will case a curve. Because now here, as a hinge is there, so vertical reaction is there and horizontal reaction.